Yeah. You can do one more question. Do you have one?
Yes, I do.
Sure. Go ahead.
Okay. One question, just like maybe a technical question. Question 21, for some reason did not register. It said 0 out of 0, but my answer was correct. So and it did it 2 times.
What was the question?
Suppose the daily growth received from certain sales and simple, I think it's forward calculation. And I mean, like, the answer was right. It said correct answer, but it did not register. It says 0 out of 0. It didn't give me the point.
I said it was right.
It was right. So I was just asking, is that how it's supposed to be? Because there's 42 questions.
That seems like a strange way to how it's supposed to be.
Okay, then I'll talk to you later about
Yeah,
this.
do you have a screenshot of it?
Yeah.
Okay, perfect. Yeah. So let's take a look at that after.
Okay, sure. And then there's question 42.
Okay, what is that number?
Okay. It just says mean 5,000, standard deviation is 1,500. What is the approximate probability that the next day will result in the value of daily gross receipts will be more than 10,000?
Okay.
I kind of do that question.
So I'm guessing the gross receipts are normally distributed?
Yes, because normal.
Okay. So it's something that looks like this. How can we solve this? We want to find the probability that the gross receipts are greater than 10,000. What will I do? Is this a forward or a backward calculation? Forward. It's a forward? That's right. So what do we do first?
We're going to solve for the z-score.
We can solve for the z-score. So in picture form, we have this normal distribution. And we're looking at something like this. And it wants the probability of being greater than 10,000, so that's like this area here. And the way we can do that is first solve for the z-score. So x minus mu over sigma. And then, where do we go from there?
Sorry, why is it 10,000 minus 5,000 rather than 1,500? Is it the test?
Yeah, I just moved the decimal places. You should get the same answer. So you could do it. 10,000 minus 5,000 divided by 15.
I got 3.33.
I mean, I don't know.
Yeah, it's 3.33 no matter how you do it.
Okay, so this should be 3.33.
Yeah.
Someone else wanted to double check. Yeah. You got it. Someone else got it? Yeah. 3.33. 3.33. All right. So in the z-score gets scale. 3.33. I'm looking at this area here. And so, how do I find that? What do I do? Chart. I use the chart. Yeah, I use the table. That's why I didn't bring one of those either. Yes, sir.
The only part that I thought about is like, okay, if the mean is $5,000, right? That means it's the middle. So $10,000 should be, complete this other kind of that's what I was thinking. If the $5,000 is in the middle, $10,000 should be at the end, and there's nothing.
Yes, and that's true.
Okay,
That logic's
so
still fine. So you look up 3.33, and what do you get?
okay, gotcha.
Point.
0.999.
0.9995. Okay, and then what is that area for this picture?
0.0005.
Yeah, so this is like the unshaded part, and so therefore this is going to be like 0.0005, something like that. So it's going to be 0.
And you would allow 0 for that.
Whatever it wants you to round to.
Okay.
So if it wants you to round to the third decimal place, I would just round this to 0.001. So round it up because we're 5 and above. Well, I mean, if this homework question was fine, then it's hard to make sure all completely clear.
No, I mean,
Oh, yeah. Is there another homework question?
Can you tell me what the number is, the sheet number 0.0?
Yeah, just 1 minus this. So 1 minus the 0.9995. Any other questions? Okay. So,
Or I have two general questions.
Okay.
What is the difference between standard normal distribution and normal distribution?
that's a small question. Does anyone know the answer to that? Yeah, go ahead.
Yes.
The standard normal is it's when you have a mean of 0 and a standard deviation of 1, while a normal distribution is just you have a mean and a standard deviation.
Yeah.
That follows the bell curve.
That's exactly right. So normal distribution can have any center and any spread. The standard normal specifically has mean 0 and mean deviation 1. And that standard normal is all that we have a table for. We only have a table for the standard normal.
so what was that answer to that question? The standard normal can have.
The standard normal only has mean 0 and standard deviation 1. A normal distribution could have any mean and any standard deviation. It doesn't have to be mean 0 and standard deviation 1.
Can you describe what is convenient sampling?
Yeah, that's one thing that I completely skipped over. Okay, so the very last question on the homework is about different sampling methods. So there's actually, we use the document, but I'm not going to use it for this today. So there are 6 different sampling methods that we typically talk about in class. And sampling methods in general, so the whole idea of sampling methods are that they are ways for us to take samples. So a sampling method is like a way to retrieve a sample from some population of interest. And so 2 of the ways that are most commonly done are called convenient sampling and voluntary response. 2 of the most common ones are convenient sampling, voluntary response. And I usually just group these 2 things together. So they're slightly different. So the whole idea of convenience or voluntary response sampling, these are ones that are maybe most commonly done because they're easiest to do. So you can imagine if I wanted to understand whether we should build a Starbucks in the lobby downstairs, a convenient sample for me to ask would just be to ask the people in this room. So that would be one way for me to get a sample of opinions on whether or not that should happen. Right? And that would be convenient. It would be very easy. And at the same time, via voluntary response, you could say, I'm not going to answer your question. I don't care to give you my response or my information. And therefore, I'm going to choose not to. And therefore, it's a voluntary response. So if I asked you something that had maybe some sort of like political or religious standpoint, and maybe it was slightly controversial, you might choose not to give that information to me. Although if I asked you about this Starbucks in the lobby, you might just be like, yeah, I'll tell you my information. Does that make sense? So voluntary responses tend to have more of an online presence. So voluntary responses tend to be like if someone sends you an email with a survey, or if they have like something up on their website that you can take, or after you go to the website, they always have those things that pop up over anything that you actually want to see. They say, hey, take this really quick, and we'll give you $1 off of whatever you purchase in the site or something. So those are ways of getting like voluntary response information. It's kind of like in the online era. Does that make sense to everyone? So the other ways that we can collect data and that we can sample are maybe better. So there's something called the simple random sample. And I think on the homework, they abbreviate this as SRS. So there's something called a simple random sample. And essentially, the idea for a simple random sample is that every individual in your population should have an equal chance of being chosen. Right? So if I'm truly interested in the opinions of everyone at the university, for me to truly take a simple random sample, everyone should have an equal chance of being selected as a part of my sample. So if I had all student ID numbers and I randomly choose 100 of them, that's a simple random sample. Now, if I somehow think that this is a simple random sample of students at the university, I'm probably mistaken, right? Like, there's something particular that means that you're in this room that makes you different than maybe people who are on their area campus this morning. Yeah, go ahead.
So question 5 said, and I guess the answer to that is false. Convenience sampling is when a group of individuals is invited to respond and people who do respond are counted.
Yes.
So that will be an example of
Voluntary response, right? That's like a direct interpretation of the voluntary response method.
so people choose or not choose to respond.
Exactly.
And then convenience sampling is like, here, I'm here, let's...
So I'll select you as part of my sample.
Okay.
Okay. So simple random samples are essentially just saying every individual in your population has an equal chance of being chosen. Then there's systematic. Systematic sampling is essentially just choosing like every 10th individual or every 5th individual or every 8th individual as a part of your sample. Right? So it's like a systematic way of choosing your sample of interest. Makes sense? So if I have this piece of paper with everyone that I could want to sample, and I just choose every 5th or every 10th, that would be a systematic sample. And then the last two, one of these is called stratified. And so the two that maybe are best, quote unquote best, are probably simple random samples or stratified samples. I'll explain why. And then the last one is called cluster sampling method. So for stratified samples, essentially, if for whatever information you're trying to get, or whatever information you want to know about, you know that there's a particular characteristic about your group of interest that is going to make a difference in the questions that you ask, right? So if I'm asking a question where your gender might play a role in how you answer the question, I'll make sure that I equally weight both genders. Does that idea make sense? Or if I think the college within, if I think that the college that you're in within the university is going to impact how you answer a particular question, I'll make sure that I get weight from every single college. And I could either do that proportionally, or I could do that equally, right? So I could just choose 10 individuals from every college, or I could say, well, the business school is about 30% of students, so I'll choose 30% of my sample from there. And about 10% of them are in this college, so I'll choose 10% of my sample from there. And then another 15% are in this college, so I'll choose 15% from there. And that'll make up my sample of interest. So I make sure that every group that needs to be represented actually gets represented by my sample of interest. Does that make sense? Okay, so cluster sampling, similarly, is if you have these groups, you might just choose to sample all of one group and like ignore all the rest of the groups, and that's cluster sampling. And maybe you could do something like that if